9th standard students, in this video I am going to continue the lesson atomic structure. In the previous video we learnt that Rutherford and Bohr's model of an atom, and also we learnt about properties of nucleus and neutrons. Now let us know about subatomic particles in atoms. Matter is made up of atoms. An atom is the smallest unit. Atoms are composed of three different types of subatomic particles. They are protons, neutrons, and electrons. Protons are positively charged particles. Neutrons are uncharged particles. So the charge of neutron is 0. And electrons are negatively charged. The negative charge of one electron balances the positive charge of one proton. Both protons and neutrons have a mass of 1, while electrons have almost no mass. Protons and neutrons together make up the nucleus of an atom. Hence, they are called as nucleons. The electrons are negatively charged particles. These electrons revolve around the nucleus in different circular paths called orbits or shells. The modern periodic table is arranged in such a way that all the elements have an increasing atomic number and subsequently increasing mass number. Do you know what is mass number and what is atomic number? Let us know about atomic number and mass number. Atomic number and mass number are always whole numbers because they are obtained by counting whole objects like protons, neutrons, and electrons. The sum of the mass number and the atomic number for an atom corresponds to the total number of subatomic particles present in the atom. What is an atomic number? The total number of protons in the nucleus of an atom gives us the atomic number of that atom. It is represented with the letter Z. Atomic number is used to identify the element. The atomic number of an atom is equal to the number of protons in the nucleus of an atom or the number of the electrons in an electrically neutral atom. The atomic number is equal to number of protons is equal to number of electrons. For example, in a sodium atom, there are 11 electrons and 11 protons. Thus, the atomic number of sodium atom is equal to number of electrons is equal to number of protons, that is 11. What is mass number? The number of protons and neutrons combined to give us the mass number of an atom. The mass number is represented using the letter A. As both protons and neutrons are present in the nucleus of an atom, they are together called nucleons. Mass number is equal to number of protons plus number of neutrons. For example, an atom of carbon has 6 protons and 6 neutrons. Thus, its mass number is 12. To write the notation of an atom, we need to know the symbol of the element, the atomic number and the mass number. The mass number of the atom written above the symbol as a superscript, and the atomic number is written as a subscript. For example, nitrogen is written as N with a simple with the superscript 14, that is mass number, and a subscript 7, that is atomic number. So 7 is the atomic number and 14 is its mass number. Now, shall we calculate the number of neutrons? If we know the number of protons and the mass number of an element, we can also calculate the number of neutrons simply by subtracting its atomic number from its mass number. Number of neutrons N is equal to mass number minus atomic number. For example, the number of neutrons in one atom of magnesium with mass number 24 and atomic number 12 is 12. Let's solve the following. Fluorine atom has an atomic number of 9 and a mass number of 19. Can we determine the number of protons, neutrons and electrons in it? There are 9 protons because the atomic number is always equal to the number of protons present. There are 10 neutrons because the number of neutrons is always obtained by subtracting the atomic number from the mass number. So number of neutrons in the fluorine is 19 minus 9 is equal to 10. There are 9 electrons because the number of protons and the number of electrons are always the same in an atom. In the previous video, we already learnt that electrons occupy different energy levels called orbits or shells. The electron configuration of an atom is the representation of the arrangement of electrons. These electrons distributed among the orbital shells and subshells. This distribution of electrons in different orbits or shells is governed by a scheme known as Bohr and Bury scheme. Now, let's know the rules of Bohr and Bury. First rule is the maximum number of electrons that could be present in a shell is given by the rule 2n square, where n is the orbit number or energy level. Example, in first shell, n is equal to 1. Then the number of electrons is equal to 2. Similarly, for other shells, maximum number of electrons present as shown in this table. In K shell, the number of orbits is 1. So the maximum number of electrons calculated by the formula 2n square. So 2 into 1 square is equal to 2. In N shell, the number of orbits 2. So 2 into 2 square is equal to 8. M shell, number of orbits are 3. So 2 into 3 square is equal to 18. In N shell, the maximum number of electrons are 32. The second rule is the shells are filled in a stepwise manner. Each shell can contain only a fixed number of electrons. The first shell can hold up to 2 electrons. The second shell can hold up to 8. That means 2 plus 6 electrons. The third shell can hold up to 18. 2 plus 6 plus 10 and so on. The general formula is that the nth shell can in principle hold up to 2n square electrons. Then the third rule is the shells of an atom cannot accommodate more than 8 electrons. Even if it has a capacity to accommodate more electrons, the presence of 8 electrons in the outermost shell of the noble gases makes the atom very stable. Electron configuration of calcium. Atomic number of calcium is 20. Number of protons is equal to number of electrons. So that is 20. The first shell can accommodate 2 electrons. So K shell is equal to 2. Second shell can accommodate maximum number of 8 electrons. So in L shell the number of electrons are 8. Third shell can accommodate maximum of 18 electrons, but if we put remaining 10 electrons, it will against the law, that is outermost electron can accommodate 8 electrons. So it will accommodate only 8 electrons. So the number of electrons in M is 8. Now the remaining 2 will be in N, that is outermost shell. So the configuration is 2, 8, 8, 2. Geometric representation of atomic structure of elements. This geometric representation of atomic structure of elements is used to know the mass number and atomic number of an element. Here is the geometric representation of oxygen atom. Mass number of oxygen is 16. Atomic number Z is equal to 8. Number of neutrons is equal to A minus Z. 16 minus 8 is equal to 8. So number of protons is equal to atomic number, that is 8. Number of electrons is equal to number of protons, so that is 8. Then electronic configuration of oxygen is 2 and 6. Now let's know about valence electrons and valency of an atom. The electrons present in the outermost shell is called valence electrons. It can participate in the formation of a chemical bonding or formation of a molecule. Molecules are formed by chemical bonding as the force of attraction between the atoms. About this chemical bonding we will learn later. One of the easiest way to find valence electron is by checking out the elements placed in the periodic table. Here is the list of the number of valence electrons present in the different groups in the periodic table. Alkali metals is a group 1 metals. They have a valence electrons 1. Alkaline earth metals in group 2, the valence electron 2. Boron group, that is 13th group, that is valence electrons 3. In carbon groups, the valence electrons are 4. In nitrogen group, they have valence electrons 5. Oxygen group have valence electron 6. Halogens group have valence electrons 7. Then noble gases in the 18th group, they have a valence electrons 8. The valence or valency of an element is a measure of its combining capacity with other atoms when it forms chemical compounds or molecules. What do you mean combining capacity? Some atoms like to donate or gain electrons, while other atoms share the electrons to combine with another atom. This is known as combining capacity. Valency of the elements having valence electrons 1, 2, 3, 4 is 1, 2, 3, 4 respectively. An atom tends to lose electron if it has 1 to 4 electrons in its outermost orbit. When an atom donates these free electrons, it has positive valency. If valence electrons of an atom is 3, then its valency is 3. We can able to understand this by calculating the valency of sodium. The atomic number of sodium is 11. Z is 11. The electronic configuration of sodium can be written as 281. The 281 electrons are distributed in the shells K, L, M respectively. Therefore, valence electron in sodium is 1 and it needs to lose 1 electron from the outermost orbit to attain octet. Octet means 8 electrons. To complete the shell, outermost shell, they need to lose 1 electron. Hence, the valency of sodium is 1. Valency of the elements having valence electrons 5, 6 and 7 is 3, 2 and 1 respectively. An atom will gain electrons if it has 4 to 7 electrons in its outermost orbit. In such cases, it is easier to accept electrons rather than donating it. Therefore, we determine the valency by subtracting the numbers of electrons from 8. If the valence electrons of an atom is 6, then its valency is 8 minus 6 equal to 2. We can able to understand this by calculating the valency of chlorine. The atomic number of chlorine is 17. The electronic configuration of chlorine can be written as 2, 8, 7. So these 2 electrons in the K shell, 8 electrons in the L shell and 7 electrons in the M shells. Therefore, valence electron in chlorine is 7 and it needs to gain 1 electron from the outermost orbit to attain octet. So to complete the one orbit with the 8 electrons, it need to gain 1 electron. Hence, the valency of chlorine is 1. All noble gases have 8 electrons in its outermost orbit. Noble gases having completely filled outermost shell. So they have 0 valency. For example, the electronic configuration of neon is 2, 8. The outermost shell completely filled with 8 electrons. So valency is 0. So dear students, I hope you understood about atomic number and mass number. Atomic number is equal to number of protons is equal to number of electrons. Mass number is equal to number of protons plus number of neutrons. The electrons present in the outermost shell is called valence electrons. We will meet in the next video. Thank you, students.